to example 3. All right, so you're definitely going to need the diagram. You're going to need this diagram. So go ahead and pause the video and draw that. You're making a fun little design here. You're dividing the wall into orange and blue sections along JK. Will the sections of the wall be the same size and shape? Will they be congruent? Explain. So basically, if I look at this diagram, we have two trapezoids or two quadrilaterals, the orange one and the blue one. So I need to show that the orange quadrilateral is congruent to the blue one. So instead of a triangle, it's a quadrilateral. So I'm going to have to list 4 pairs of angles and 4 pairs of sides, and then I'm going to have to do my congruency statement. So I'm going to start with the angles. So I'm going to start with angle D is congruent to angle B. So that's right here, D and B, and that's just given on your diagram. So I'm not going to do like a full proof, I'm just going to sort of explain. That was given because they're both right angles. Same thing with angle A and angle C. Those are also right angles, also given. So I also need to prove that angle 1 and angle 4 are congruent, and that angle 3 and angle 2. And we do have parallel lines cut by this transversal, so 1 and 4, angle 1 and 4. Those are alternate interior angles. And same thing with angle 2 and angle 3. Okay, for the sides, I may need to kind of move this over a little bit and erase this a little bit. Hopefully I can erase my picture. Okay, good. All right, so let's start with DA. DA has 3 tick marks, right? DA has 3 tick marks, so that is congruent to BC, which also has 3 tick marks. That was given to us in the diagram with the tick marks. What else is given to us? I would say that up top with 1 tick mark, AJ is congruent to CK, also with 1 tick mark. That's also given because it has the tick marks. All right, then I also have 2 tick marks and 2 tick marks. So I'm going to say that DK is congruent to BJ, given. And then the last one that is not marked, I'll make it red, is line JK, right? Because I have this shape right here in orange, and then I have this shape. So they're sharing that same side. They're sharing that same side. So JK is congruent to JK. It's congruent to itself. What property is that? Symmetric, transitive, or reflexive? If it's congruent to itself, that is the reflexive property when it shares a side. So I've listed all 4 angles, 4 sets of corresponding angles that are congruent, all 4 sets. Now I can say quadrilateral DAJK. DAJK is congruent to quadrilateral BCKJ. And that's my congruent statement. All right, example 4. So draw the diagram. All right, find the measure of angle BDC. So we're trying to find that big diagram. So let's think about what we know here on the picture. Let's just fill in what we know. So I know that these 2 angles with 2 red tick marks are congruent. This is isosceles. So these are both 30, 30 and 30. If I think about this little triangle CND, see if you can think about what would angle N be. If 30 and 30 is 60, This is 120 degrees. Okay. Then I have some linear pairs, right? This is a linear pair. So these two angles are going to be 60. All right. I also know that this angle, because it has that little red 1 mark, and this angle are congruent, 45 and 45. Okay. And then I could look at like this triangle, this green triangle. If I have 60 and 45, I could find that third angle. So I could add 60 plus 45, which is 105. So these angles are 75 and 75. Now, let's see, what angle were we supposed to find? We were supposed to find angle BDC. So BDC is this big angle. I just add 30 plus 75. I get 105 degrees for that angle. This is not the only way you could have solved it, but that's how I did it. All right, last example. Use the information in the figure to prove that triangle ACD is congruent to CAB. It gives you a bunch of stuff that's given, and you're trying to prove that the two triangles are congruent. All right, so draw your diagram, pause the video, set up your table. All right, I'm going to start with the side lengths. Oh, I could start with the angles. I'm just choosing to start with the side lengths. So I'm going to say that AD, because it has 1 tick mark, right? AD is congruent to CB. That's also given. Okay, and that's given right up here. What else is given to us? DC is congruent to BA. That's given. And that's right here. So I have 2 pairs of side. For my third side, I have AC. So I'm going to say AC is congruent to AC. And think about from the last problem or 2 problems ago, what is the reason? See if you can figure that out. That is the reflexive property. Reflexive property. So now I've got all 3 sides. Now I need to do the angles. So I'm going to start with ACD, excuse me. Is congruent to CAB, and that was given to us. Okay, and then I also have CAD is congruent to ACB, and that was also given. All right, so that does mean that I am missing these angles right here. So we don't have parallel lines. How do we know that those 2 angles are congruent? What were some of the theorems we went over today? If we know 2 of the 3 angles, we can conclude the third. So I'm going to say angle D, that's right here, is congruent to angle E, and I'm using the third angle theorem. All right, so now that I have all 3 sides and all 3 angles, I can go ahead and end with what it's asking me to prove right here. Triangle ACD is congruent to triangle CAB. And how do we know that? Because corresponding parts are congruent. All the corresponding parts were congruent. All the sides, all the angles. So it's kind of a lot of work. As we get through this chapter, we're going to learn some shortcuts. So instead of having to do all 3 sides and all 3 angles, there will be some shortcuts. All right, so here's the summary. What are corresponding parts? What are congruent figures? How do you know if 2 figures are congruent? So those might be able to be condensed into 1 sentence. And then lastly, in purple, summarize the third angle theorem. Have a great day.